Yeah, good afternoon to one another. Myself, Dr. M. Durga Prakash. Currently, I'm working as an associate professor at SRM University, Andhra Pradesh. So, let me share before going to presentation. Exactly 10 years back, I have passed out from this institution. I completed my PhD from IIT Hyderabad in 2015, and then started my career in different universities. Presently, I'm working as associate professor at SRM University. Your voice is not audible. Yeah, I think so. Today I'm going to present on this title of this talk is geometrical study and performance analysis of gold interdigitated microelectrodes towards biosensing applications. So this is my outline of these presentations. I'm going to discuss about the abstract of this research work and then introduction, objectives, methodology, result and discussion, conclusion, references of this paper. So the brief abstract of this work is like general. We know the biosensors. Any biosensors we are looking about the majorly on sensitivity. The sensitivity matters and also resolutions. So particularly for that, relevant to that one, we have design and simulated geometrical design of electrodes that is on interdigitated microelectrodes. What changes of different electrical field in the sensors, and also we have seen the different sensing characteristics of the device like impedance, capacitance, resistance, and also other electric fields of AC and DC on this work. And we have the compatibility of fabrication of this sensor, what are the challenges are there, what challenges we are going to face. For that we have also done the study of this work. So particularly like a clean room based fabrication of this procedure, what type of procedures is required and what are the limitations are there. And then we have explored all these geometrical relevant to parameters towards to biosensing fabrications relevant to fabrication procedure steps. And finally, we have came to the interdigitated microelectrodes as a suitable sensor platform for the traditional low electrode systems because their increased electric field strength at the same applied voltages. That study we have carried out in this work. And all these works and all we have carried out by using interdigitated microelectrodes using console multiphysics simulator software and adjusting with the interdigitated electrodes, interfringes, distance and electrodes, fringes count, all these parameters and all taken into this work. And we have observed the generated electric field strength to appropriate biosensors design relevant to that. We have done this work for this. This is the brief abstract of this work. So let me explain about the interdigitated microelectrodes. What is the structure of the electrodes and what type of design parameters we need to carry out for design work and all. So they have introduced the improved the device performance sensing parameters, particularly the electrodes distance is one of the one of the important design into interdigitated microelectrodes. So for that, like interlocking interdigitated electrodes and a gap between the electrodes to electrodes, that is neighboring electrodes, and also and what the improvement parameters relevant to like electric field sensitivity, resolutions, and the efficiencies. That is also matters into the designing of the interdigitated microelectrodes. And this is the structure of the interdigitated microelectrodes. Like you can see the base materials, what base materials we are going to fabricating or designing with the materials, and what are the metals interconnections or bonding pads we are using for the relevant to sensors for different applications. And this is the structures. You can see the interdigitated electrodes, how it will be that designed properly in that. So this is the general structures of the interdigitated microelectrodes. So in these structures, notably like particularly a simple, adaptable, inexpensive way we are going to designing for different applications. That is one of the good platform for different applications. So we have come up with the designs with the interdigitated distance we have taken as a main important parameters, and we have studied about the DC resistance and AC resistance for different electrical parameters study characteristics point of view. And this is the methodology and design what interdistant microelectrodes we have designed according to the design parameters what values we have used under. So particularly we have analyzed the electrical field performance of interdistant microelectrodes by adjusting the two geometrical factors, that is interfringes gap G and the number of fringes. This is one of the major design parameters for the IDE. And this particular design interfringes distance range from 1000 micrometers to 250 nanometers in 8 intervals with 2 to 9 fringes where we have taken for this consideration of this design. And the electrical biosensing factors including resistance, capacitance, and impedance, that is R, C, Z, dependent with the electric field evaluated geometrical parameters crucial in these designs that we have used with this design proper way of designing of IDE electrodes. So you can see this is the structure of the design, and the parameters are like total width, depth, and bandwidth. All these things under the ranges and all it's given from 1000 micrometers to 250 nanometers range way we have designed for the interdistant microelectrodes design. So, and then the design parameters, what we have taken relevant towards biosensing applications. So particularly like we have simulated for relevant to sensing parameters, what we required, we have achieved by simulating new different designs for different dimensional parameters using with the COMSOL simulation parameter software. And then finally, we have achieved for the sensing parameters, what we required, or what all sensitivity is required, and what all the resolution is required. Accordingly, we have changed different parameters such a way that we have achieved the sensing parameters what we required. So particularly you can see this is the what the design parameters according to that we have simulated in COMSOL multiphysics software. Electric field mapped into images of the G is 250 nanometers and 80 fringes, one of the particular parameter of the design I'm showing here, but like that way we can, there are like hundreds of designs we have simulated, and out of that one of the design I'm showing here with the G 250 nanometers and 80 fringes as a phase 3 of the one of the simulated structures I'm showing. With these structures, like these the fringes distance G changes with the number of fringes also changes fixed with the different interdistant electrodes. And you can see the results here, like I'm showing here, there are 8 phases with the phases, each phase width and the gap, and also the G values for the interdistant microelectrodes and number of fringes what we have carried out for this work, and accordingly what electric field we have achieved for the each phase, and average electric field, and field homogeneity of these terms for calculating the errors of this electric field magnitudes mapped into different phases. So particularly we have done the work for 8 phases for the different G value, W value, and height of the interdistant microelectrodes. So for all these things, these are the simulation results we have achieved for electric field versus rectangular interdistant microelectrodes for various G value, F value, like this way, total 8 phases. So I have shown with the total 8 phases for these graphs. And finally, like based on this n number of different simulations data, and towards biosensing, which the parameters is relevant or it is good fit for sensing applications and all we have targeted. And then finally we have like targeted one particular design for sensing applications, and we are planning for the fabrication process for different biosensing applications, also particularly biomolecules detections and different uh, accelerations, different apart from biosensing applications also. So the conclusion of this work is like we done the work performance analysis everything on the console, and particularly we have understand about the electric field, how about the different parameters, interfringes distance and the number of fringes, with how it is varying about the device, and all we have studied about that one. And also the G range is from 1000 micrometers to 2000 to 250 nanometers, that is the phase 1 to phase 8, with the maximum electric field, how much it is generating, and all we have seen that is 2.57 volts per meter at 80 fringes in the phase 8. And also electric parameters like resistance, capacitance, and impedances are how it is changing depending on the strength of the generated electric fields between the different electrodes sizes. And that is the electrical transduction based biosensors platform. It is suitable for different applications, improved sensitivity and resolutions for that. And finally, this study will examine the how we can go for further, based on different fringes height and width of the generated electric fields. And also it is identical work for done for both rectangular and also ring shaped interdigitated microelectrodes for altering the different electrodes materials, and also selecting appropriate electrodes design to improve the one of the biosensing requirements for such examination study analysis, that also we have carried out for this work. So that's about this work, and these are the references for this one. Thank you for this.